So, hey everyone, my name is Irit. I've been working on the telemetry project for a couple of years now, maybe even more. And yeah, let's see what we have. So today we're gonna have an overview for telemetry. We'll understand better the motivation for it. We'll talk about some architecture. We'll have some dashboard demos, and we'll see some success stories that we had so far. So Ceph telemetry means that clusters phone home to report anonymized, non-identifying data about their installation, configuration, and so on. The data is then aggregated and presented in public dashboards, and detailed data is available in private dashboards. Very important for us to emphasize that by default, telemetry reporting is off, and users need to explicitly opt in by agreeing to a license either by a CLI command with Ceph telemetry on, or by using a Ceph dashboard wizard. If you want to see a report for a sample for a telemetry report, you can do that with the CLI command or with Ceph telemetry show all prior to Quincy. And in Quincy, we use Ceph telemetry preview all. So the telemetry report is broken down into several channels, each with a different type of information. And once the user is opted in, telemetry channels can be turned on or off. We currently have 5 channels. First one is a basic channel that has information about the Ceph and kernel versions, the cluster size, how many daemons are in the cluster, and so on. This channel is on by default, again, in case the user is opted into telemetry. And then we have the crash channel. It has information about where in the Ceph code the crash occurred. We'll talk more deeply about that soon. And this channel is also on by default. And then we have the device channel, which collects information about health metrics of the devices, mostly smart. This one is also on by default. And then the ident channel has the option for users to share their contact details, like their email and what organization they're from. This one is, of course, off by default, and it has to explicitly be turned on. And in Quincy, we added the perf channel, which have all sorts of perf counters of the cluster, and this one is also off by default. I want to touch about privacy. This is really important to us. So in case users are opted into telemetry and we add new data to the reports, we require users to opt in on a Ceph upgrade. And in Quincy, we changed a little this design that allows users to keep sending whatever they're currently opted into, the current data model version, but they need to re-opt in for any new deltas. The reports do not contain any sensitive or identifying data like pool names, host names, object names, or object contents. We really just care about, we don't care about who owns the cluster. We just care about the telemetry information in it. We go to, we put efforts in anonymizing everything we can. So the cluster is assigned a random UID, which is specifically for telemetry. This is not the FSID of the cluster, and the FSID is not reported. We also remove the disk serial ID. It is redacted, and this is relevant for the device channel. And the IPs are never stored on the backend. And in order to enhance privacy, we are sending 2 separate telemetry reports, one with the anonymized cluster data and the other with the anonymized device health metrics. These are sent into 2 different endpoints. Now, why would we want telemetry to begin with? So for developers, it's very helpful for us to get feedback on what features are in use in the wild. We can learn about the upgrade cadence and to see how to learn about the version adoption rate. We can also know what hard disks and SSDs model users are deploying. And this also helps us to create an open data set of device health metrics. And the reason we want to do that is in order to have better device failure prediction models. And I'll talk about it very soon. The telemetry data also help us to learn about new bugs and issues as soon as possible. And we can also prioritize issues better having this information by focusing on the most common bugs. We can also learn and discover crash trends through versions. And once we find the solutions for those bugs, we can verify that they actually work by identifying regressions if they occur. And this is all thanks to the crash channel. And for users, users can validate their installations by looking at what is common, what usually Ceph users are deploying. They can preemptively mitigate failing devices by donating and contributing the smart data. And this is a bit of a longer term goal that we have here. So once we have a more accurate device failure prediction models, we can help the user understand that a device is about to fail, which helps to reduce downtime in the cluster and shift downtime to a maintenance window and not to have it on a peak hour. Another big motivation for users is they don't need to actively report issues or open tickets for each crash that they have in their clusters. And they can use the open data set of the crashes to better understand an issue. So if you see a specific issue on your cluster, you can search it on our bug tracking system and see if it's a real bug. And if it's a real bug, you can learn what version it is fixed in. So I'll talk quickly about the workflow. We have on the Ceph cluster side, the manager that collects information from all of the daemons in the cluster, and then it compiles a couple of reports, and then it sends it to the telemetry backend, where we have an Apache server and a Postgres database. And we have a couple of Grafana instances that get information from the Postgres database. Now let's see what we have with the cluster data so far. So we can learn about the breakdown by versions and to see the upgrade cadence and version adoption rate that I mentioned earlier. And we also have panels to learn about capacity density in the clusters that are reporting in the wild. So we can take a look at the public dashboard. I added the link for that in the Etherpad as well. So you can see that there are nearly 2,000 active clusters reporting telemetry and just about 600 petabytes, which is amazing. The blue bump here is Quincy. We released it a couple of weeks ago, and you can see that there are already about 70-something clusters reporting Quincy. And then we can see the actual number of daemons that report Quincy as well. So there are about 3,700 daemons that were upgraded to Quincy already. And we can see all sorts of other breakdowns of information, like to learn about the total capacity by version. So this help us understand if users in the wild are adopting new versions and how quickly that happens. This dashboard lets you see breakdowns by major and minor versions. So let's see, we want to take a look, for example, at Pacific, but we want to see all the breakdown by minor versions in Pacific. So we'll just ask for a display by minor, and we'll ask specifically for Pacific. So here you can see the adoption rate. This purple is 16 to 7, and it was released about the end at about it was December, right, of 2021. So you can see how it is being adopted by users in the wild. We have some other panels here. I will not get into everything. I really encourage you to take a look at them. And here we have complete dashboard just for the breakdown for capacity density of all of the reporting clusters. Let's take a look at a cluster X-ray page. This is a page of the Giba cluster that we have in our lab. So we can learn about how old this cluster is, how many hosts it has, the total unused capacity for in a time series manner, and then to learn about the pools and PG_num of this cluster, to learn about the latest metadata of this cluster. We can see the reports, we can see individual raw reports for each of these clusters, like in the cluster X-ray page. We have latest pools information, and we can learn about recent crashes that happened in this cluster as well. So this was the cluster data. I'll talk about the device data. If you have any questions, please feel free to let me know.
There was
All right.
one that Neha answered it, but the question was, are these 1,846 clusters deployed at a customer site? And Neha answered they're all clusters.
Oh, yep. Thanks.
So what is the typical, is it only for the upstream deployments? If somebody deploys like Red Hat or canonical distribution, it will likely not report?
They can. It's up to them. So as I mentioned at the beginning, every user, every operator has their own choice. So if they are not, if the cluster is not air-gapped, they can opt into telemetry if they want to, but they have to explicitly do that. It does not happen in the background or anything like that. They explicitly have to opt in. So it can either be via the CLI with the Ceph telemetry on command, or via the dashboard. And with the Ceph telemetry on command, we do require to enter the license, so it has to be explicitly manually done.
Okay, I was just asking because the comment was that all those clusters in the telemetry are upstream clusters. So that means that there are no clusters running the version from a distributor.
Sorry, the audio was a bit broken for me. Can you just repeat the last sentence?
Yeah, the comment was that all those clusters reported in the telemetry are upstream clusters. Does it mean that there is no single cluster reporting that is kind of Red Hat Ceph or canonical Ceph or OS Nexus Ceph?
It is mostly upstream. We did see some reports from different OS, such as from different distributions, such as Red Hat distributions and SUSE's distribution. But this could also be, like a test cluster or anything like that. We don't know. We don't know these clusters. It's all anonymized, and unless the user chooses to identify themselves, we have no idea the organization.
Yeah, I guess to emphasize that, I think the answer is most likely they're all upstream. It is quite possible that there's one-off cases where a distribution like Red Hat or Canonical Ceph has enabled telemetry, but at the moment we don't differentiate.
Yep. Thanks, Neha. All right, so going back to the device data. As I mentioned, we can learn about hard disks and SSDs users are deploying, and we have a breakdown by vendors and models. So you can see that easily Seagate is the most popular device that users are deploying with 31,000, nearly 32 even devices. We can take a look at breakdown by models and learn that there are 8 devices that report 20 terabyte each. We can also see, for example, for Samsung, that most of the devices are indeed SSDs and NVMe, and see the breakdown as well by models. So the reason we collect health metrics, which is currently just smart metrics, but we are working in order to add vendor-specific metrics as well. The end goal here is to provide a disk failure prediction service. So everyone knows that in order to have a good model, we need a lot of training data. And currently, the only open data set out there is by Backblaze, which is really nice that they provide it. But the problem is that it is limited and it's not diverse enough. So we are opening the device data telemetry. We have an open data set which can be downloaded from our website. And we call for researchers to do an open research about this data and come up with better models for predicting failures. And we also have plans to collaborate with other projects in order to create a larger data set for this. All right. The crash data that we have from the crash channel has raw crash reports, which contain, each one of them contain the crash ID, which is basically a timestamp plus a random UUID. It has information about the daemon type and name, the Ceph version of the daemon. It has its backtrace, the backtrace of that crash specifically, and it has information about the distribution and the kernel version. And if it was, if the crash happened due to an assert, we'll have this information as well. Now, in case the user has enabled the basic channel as well, or did not disable it, we'll have information about the cluster. So we can learn about the available and used capacity of the cluster at the time of the crash, the number of daemons, their metadata, and so on. The thing is that we need to find patterns among these raw crash reports. So it will be, it will make more sense for developers to take a look at them. The problem is that same issues can have different backtraces, and this can happen due to different Ceph versions. The code has changed, so the backtrace looks a bit different. There could be differences due to different compiler versions or compiler optimization. So one way that we found to be effective is to sanitize the backtrace. So in the backend, we have a crash processor that looks at all of these raw crashes and identifies similarities among them by taking those raw crashes and sanitize their backtraces. And it does that by removing the offsets and addresses from all the frames. And then it applies some search and replace patterns and filter out patterns from some frames that are just noise in the backtrace. And then it adds the assert data if it's there, and it calculates the signature using a SHA-256. And this crash processor supports multiple generations or recipes of signatures, which allows for backward compatibility. So it also supports the version of the crash signatures that we have on the cluster side. And then it populates the database, creating all of these signatures for the raw crashes. But just having the data is not enough. We need to take action in order to do something with those crash reports. This is why we have the Redmine bot, which queries the database for the most recent crash signatures, and then it maps those crash signatures into Redmine issues by searching Redmine for these signatures. And if it finds an existing issue, it updates it. Otherwise, it creates a new issue, and it knows how to pick up the right project in Redmine for that. So the information that the bot updates is some essential information from the telemetry database, such as affected versions, sanitized and raw backtraces, and it links to a dynamic dashboard that we'll see in a moment. Another important thing that the bot is doing is identifying regressions. So in case there was a crash report that it synced with Redmine, and we found that it was a real bug, and we fixed it. But then we receive new crash reports with a newer version than the one that has already been fixed. The bot will open a new issue, and it will link it to the original issue, which is allegedly fixed. And then in case the same thing happens, but on an older major release, but with a newer minor, we'll just send an email about it, because it might not be a real issue, and we don't want to spam developers too much. So we have custom queries for the crashes that we synced. So first one would be the crash triage. For this one specifically is for Ceph, for the entire project. So we will have all the crashes here that are new, that are opened by the telemetry bot. If you want to take a look, for example, at just the Blue Store crashes that were opened by the bot, you can choose those custom queries from the sidebar here. So we have both the queue and the triage. Queue has everything which is open, and the triage just the new ones. The latest telemetry crashes sync that we had was mainly for 16.2.7 crashes. And it's very important to emphasize here that not all crashes mean Ceph bugs. It could be hardware issues, it could be environment or resource limitations or configuration issues, or it could be issues with other dependencies as well. So there might be many signatures synced with Redmine, but they not all represent real Ceph bugs. It's really important to emphasize that. All right, so we can take a quick look at the architecture on the server side for the crash telemetry. So here we'll have the telemetry report lands on a REST API. It goes to the database, and then the crash processor sanitizes the backtrace and generates the correct signature. There's a Grafana instance that knows to query this database. Of course, the crash processor updates the database with all of the new signatures. And then the Redmine bot syncs those signatures with Redmine. And there's another component that I will not talk about today, that its essence is to improve the signature creation for the crashes. So basically, we have a better deduplication for raw reports. All right, so we have powerful crash dashboards. They allow to discover trends in crashes versions. It allows searching by backtrace frames, by versions, either major or minor. All revisions of signatures, the assert function and condition, number of affected clusters, and to see the crash status. And it allows a drill down to cluster information, as I mentioned earlier, if you want to take a look at how big the clusters that experience a certain crash are, what versions they are currently, and so on. All right, in order to access the dashboards, developers need to have an access to the CPL lab and to be members of the Ceph organization in GitHub. Users can search Redmine for the backtrace, for specific frames in their backtrace, and for crash signatures. And I just want to emphasize here, if you manually create a Redmine tracker and you add the crash dump there, please do not remove the stack sig key. It is not a secret, and it really helps the crashbot to sync similar issues that we received through telemetry. All right, so let's take a look at the crashes landing page. So here we have all sorts of panels that help us have a bird's eye view of time series data of all the crashes and their signatures by the day. And if you want to take a look at the new crash signatures, for example, in the latest 30 days, we can take a look at that. And we can see that we have a breakdown by versions here, either major or minor. We can learn about how many clusters are experiencing this information. Maybe I will, is this better like this? I think it was maybe too small.
Yeah, it looks good.
Yeah, the font size is better. All right. So we can learn a lot about all of the crashes that we've seen in telemetry in the last 30 days. So, for example, if we see that there are 6 clusters that are experiencing a certain issue that happens only on some sort of a Quincy version, we can see it's 17.10 and 17.20. We can click on that, and yeah, it's too big. This is why it's a bit broken now. And we can see that there's a total of 11 row crashes reported. It has breakdown by versions. So just one happened in 17.10 and 10 by 17.20. We can have a look at the sanitized backtrace. And here we can click on the sanitized frame. This is a Python crash. So we can click on that and see all of the other crashes that have this exact frame in them. So not necessarily the same issue. This crash did not happen due to an assert, and here we can have a breakdown by daily occurrences, and we can learn here about the affected clusters. So we can see, for example, their usage, how big they are, and we can learn about their current and recent versions. So we can see that one of them has mixed versions, so not necessarily all the cluster is upgraded to Quincy. And here we can see the actual raw reports. So if you want to take a look at a report that was not sanitized, like with a raw backtrace, we can do that as well. And here, basically, when users identify themselves, and some users do, some users want to identify themselves with the developers. We will have a list of these users here, but I removed it here for the sake of the demo. All right. This work? All right. I want to take a look at a few examples of some success stories that we have with telemetry. So as you know, we launched Quincy a couple of weeks ago. So this really helps us to monitor crash reports of new releases, and we use that for Quincy as well. So in the example that we just saw, there were a few crashes just for that happened in Quincy as well. But here you can see that the time frame is, we took a very big window here, which is of course too big. But then we chose here in the miners versions just 17.20, which was released a couple of weeks ago. And here we can take a look. There are currently 28 crash signatures reported so far. And we can see that some of them happened in other versions as well, not necessarily Quincy. And again, as I mentioned, not all of them are real crash Ceph bugs, but it does help us to monitor and better understand. For example, this one has many affected clusters, but this can just be a problem with hardware or anything that is not related to Ceph. All right, let's take a look at some bug fixes that happened thanks to the sync with Redmine. So this one was created by the telemetry bot, this tracker. It assigned it to the CephFS project, and it filled up all the relevant versions and the crash signatures that it saw in the wild, and also one that was created on the backend. And then in the description, it has a link to the dashboard and has information about the assert that happened, the sanitized spec trace, and a sample of a raw crash dump. And it was picked up by the developers of CephFS. And there is a pull request that is fixing this issue that was seen in the wild. This is the page that was linked from the tracker. So you can see that there are a total of 2 affected clusters that reported this issue with a total of 13 raw reports. And here's the breakdown by version. Here we can, click on any of these frames and see if they happened in other, if they occurred in other crashes as well. But here we see just one example, which is the one that we're looking at. And we can see, again, the daily occurrences. And if we're curious what version the clusters currently have, so we can see that one of them actually upgraded to Quincy. So maybe it can help us narrow down if the crash happens just in Pacific and not in Quincy. Yeah, and here basically we could have the contact information details for users that identify themselves that experienced those issues. All right, now we have another example for another crash that was reported through telemetry and was also picked up by this time RGW team. And they had even backports. So this issue happened, it was reported for 16.7, but they realized that it actually went, it also happened in Octopus. So it helped us discover an issue that even though it was reported just for one version, needed to be backported even further. Now we have another use case for a tracker here that was reported by a user, and they complained about this issue that it happened in 1700, and Neha went and checked the telemetry crash dashboard, and it helped us understand that we actually saw this in telemetry already in 16.2.5. So those crash reports help to better investigate this issue, and we understand that it's earlier than whatever the user was reporting. All right, and I want to talk about this tracker real quick. So this issue was first, oh, sorry, is it this one? Yes. So it was opened by the telemetry bot, and we can see that when it was found during the bug scrub, we discovered that we need more information to debug a crash like this. And a user actually found this tracker by searching it, and it provided us with some additional information. So users can respond to whatever we see in telemetry through the bug tracking system. And I mentioned earlier that the bug can detect regressions. So we can take a look at this tracker here, that it is resolved, and the version here is 15.2.8, but we can see that a new tracker was opened recently by the telemetry bot, and it says that new crash events were reported via telemetry with newer versions than encountered so far. This happened because that tracker is related to other trackers. This is why it picked up 16.2.0, but it linked it to the previous issue. So might be a regression, might not be a regression. We have to investigate, but at least we have this option of knowing that it happened. So like I mentioned, sometimes just the raw crash reports are not enough, and users identify themselves, so we can contact them and ask for more information to better debug an issue. And this issue was first reported in a Bugzilla. You can see about a year ago, and it was picked up by the bot, and that's thanks to the fact that we had the stack signature here. So there were similar crash reports through telemetry that the bot could scan Redmine and update an issue instead of opening a new one. And we saw that we have links here to these crashes in telemetry. We can see that there are 49 affected clusters by it. And this helped to prioritize this issue. Neha, if you want to say a few words about it, because this is a recent tracker that we've been working on.
Yeah, so I think this particularly is interesting because this is one issue that we saw, as Yarit mentioned, in downstream, but we hadn't seen it in upstream. And when you look at the crash, it seems very intuitive, like it should have shown up. And clearly that was where my curiosity rose, and I checked the dashboard, and I saw that there are users that are hitting it. So clearly, there was something missing in our integration tests that was not catching it. And Junior was assigned this bug, and he did a great job of identifying why we were not catching it. And clearly, going into the specifics, there is a way in Ceph ADM to remove daemons. So there were no tests that were actually exercising the fact to reduce daemons in a cluster. In this case, monitors. So which is why we would see this. And also turns out that if you use a regular manual procedure of removing monitors, you wouldn't hit this crash, which explains why the other tests weren't catching it. So essentially, I guess that's where one extra data point helped us prioritize this bug. And this is a real issue which we are fixing, and now also reproducing in Pathology.
Thanks. And I want to take a look again at this tracker and see how. Let's say that for some reason we did not have anything we did not have the telemetry bot synced whatever we saw in telemetry with Redmine. Maybe because it was an older version, or we just haven't synced it yet. We could manually search the telemetry dashboard for it. So, for example, we can see that we have the backtrace included here, and if we scroll all the way here, we can see that there's the function name. So we can copy even a small part of it, and we can go to the search page and basically search just for the specific function. So we can leave the 5 years window, that's fine. And we can see that there are 7 crash fingerprints or crash signatures that are reporting a pretty similar issue. So the reason that they are again not all grouped together in case they are similar is we did not detect the backtraces were different enough, and the filtering out did not detect that it is indeed the same issue. So this is one thing that we're still working on improving. So again, even if you see any problem there out in the even in tautology or in downstream or wherever, and you don't find it in Tracker, please use the dashboard. You can again search just for the assert function. There was also an assert condition in this case, so if we can well, this one I guess it was good enough, but sometimes the assert condition is not very not give us too many details. So in this case, yeah, still 7, same thing. Or we could just use some frames in the backtrace. But here, it will not help us to search for frames that we filter out, because we will search only in the sanitized backtrace. So for example, if I search for this frame over here, it would better, it would probably find better results. So yeah, so you can see that there are 3 crashes that were not mentioned here. Probably a different way of execution. So, and this is an important point here. If you don't find it in Tracker, please use the dashboard. It might not be synced with Tracker yet, so that's important to emphasize. Yeah, and there are some other use cases that telemetry was very useful. So for example, we wanted to know whether file store can be deprecated. So we looked at the data that we have so far with telemetry, and produced these panels to see how many file store versus BlueStore OSDs are out there. And you can see that we have a breakdown here by major versions. So for example, in Pacific, there are very, very few daemons that are reporting file store. And if we want, we can just have a breakdown by just Pacific. For example, if you want to see the minor versions that are reporting. And I think we announced that it will be deprecated, and this data point was very helpful. So we did use the survey for that as well, and probably mailing lists. But telemetry give us real-time data, and it makes your voice heard as users. So it helps us to better understand what's going on in the wild. So you can see the ratio for BlueStore versus FileStore in 16:7. We were also asked whether the Erasure Code Clay plugin is being used in the field. So we did the same. We had panels for that, and we saw that it is being used by real clusters in the field, and there were no related crash reports to that. So another real data point to make decisions. And I think now we are even developing it further. If I'm not mistaken, it was this code was donated by a researcher, but we did not call it as a production code. But now we understand that clusters are actually using it. And telemetry data also helped us to find better tuning to the Ceph dashboard. They needed to know the magnitude of how many RBD images are deployed by Ceph users, and they had some scalability issues, and this information really helped them in order to fine-tune the dashboard. So for all the users out there, please join us with opting into telemetry with Ceph Telemetry on. You can see that it is super, super useful for us, and it helps us make a better product, more robust, and have a higher quality. So yeah, I'm happy to take any questions if you have. I see that there are questions here. Yes, so I will have a link to that as well. But basically, on that page, you can just click here and see all of the related dashboards. But I will add a link to that in the Etherpad as well. That's a good question. And how can developers access collected reports? So as I showed with cluster in the cluster page, we have all the reports here. We can see raw reports here. But if there's a need to have them in another format, we need to have access to the database. Are there any more questions?
So going back maybe to my original question about the upstream versus distributions. If the reporting, and it's understandable, if the reporting comes mainly from the upstream deployments, it is likely very skewed towards developers and maybe less to production. And then if you make decisions for future directions based on those reports, maybe they are a little bit biased towards those developers' upstream deployments. Right. So are there any plans to promote telemetry adoption by the people who use the distributions and then not upstream?
There are plans to promote it downstream, specifically in Red Hat. But I just want to say that if we take a look at that telemetry public dashboard, so they're not all developments. As we can see that there are some real clusters that are reporting here. If we take a look at the cluster distribution by total capacity, so you can see that there are clusters that are reporting that are pretty big. So these are not just development for as much as we can assume. Another thing is that there are clusters that the admins really want to report telemetry, but they cannot because they're air-gapped. And we're thinking of supplying a solution for that. So these are, again, real deployments, but they cannot contribute their data because of this issue of being air-gapped.
Going back to the development versus real cluster question, I think the scale of the cluster tells us a story about whether it's a real cluster or a dev cluster. And the other thing is most of the development only happens on the master branch or the main branch. So the version number is an indication of whether it's a development cluster or a real cluster as well.
Yeah, that's a very good point. Thanks.
Thank you. Very interesting presentation, by the way, and thanks for doing this during the holiday. Chag Sameach.
Chag Sameach. Happy holiday.
Yeah, the demo.
Detail.
Oh, sorry. Yeah, the demo. Yeah, hi. Yeah, the demo you did just like for a brief period with like the bug that I was working on was really helpful. Like just showing around like how we could find the actual like crash signature using like strings and using assert functions. That was nice. So thank you for doing that.
Thanks. I'm very happy to hear that. All of the information is there, but not yet synced with Redmine because we want to better dedupe the crashes, so we're not overwhelming developers with crashes that can be better deduped. So it's there. We just need to actively search it. Yeah. Laura, did you have a question?
Yeah, I just had a quick detail to add about the developments we're doing and or the idea we have to collect or track unavailable data in clusters. So that's not a data point that's being currently collected, but that's set in place for Reef. So essentially, the idea was that in Ceph clusters, there are ways to identify unavailable data through like PG states when PGs were last active. And there are ways to see that in the Ceph clusters right now, like through warnings that pop up about data availability by looking at the PG map. Excuse me, but there aren't ways to track that data over time right now. So we are thinking about ways that we can take that data, look at the PG states when they were last active, and calculate some sort of data availability score that can indicate how when data was available and maybe over the course of a week, your data availability score was like 80%, something like that. And then the goal is to include that in telemetry so that we can have reports of data availability tracked over time and collected through opting into telemetry. And that is an idea for the next release, Reef.
Yes, thanks for mentioning that. Yes, and this data is going to be collected in a perf channel. So yeah, we might add some highlight information in the basic channel as well. But yeah, this can really help us better understand deployments as well. Yeah, so please again, like we said, when you want to make your voice heard, please opt into telemetry. We really just care about the data. We're very open to feedback. Let us know if you have any ideas for improvement or anything we can do better. We'll be very happy to do so. And developers, please use the dashboard, the crash dashboard. Let me know if you have any questions or any other ideas. I'll be very happy to hear.
I have just one more question about the general UI of the dashboard. So the public telemetry link, is that providing more of just an overview of all of the data collected versus the sepia link, which is where developers can find the crashes? Is that the difference there?
Yes, exactly. Yes, this is aggregated data in the public dashboards. It has more of a cluster data aggregated and device data as well. And the private one is more aimed at the crashes. Yes.
If developers will want to search for crashes, they'll go to the telemetry.front.sepia link and search for crashes there with the sepia VPN enabled.
Exactly. Yes. That spec search page. I will add a link to that in the Etherpad as well. Yeah, and please remember to check the time frame here. This is really important because sometimes just last 30 days, but you actually want to see some more data, so you need to go back a little bit more. And make sure that the fields are, so if, for example, now I want to see just in the last 30 days, all of the crashes that happened, let's see, just in 16/2/7, and then I don't understand, okay, there are just 2 crashes, but that's because I have this search for this string in the backtrace. So if I move it, I'll see everything, everything on the last 30 days for 16/2/7. I can also see, let's say that I'm curious what also occurs in Quincy, any version of Quincy. So I'll add the major affected version here, and I'll see that there are 17 crashes that happened in 16/2/7 and any version of Quincy. And of course, they could happen in other versions as well, but this would be the default. And also, we can see only new fingerprints in this time frame. So, for example, this signature here was first seen in 2019 and last occurred in 2022, yesterday. So let's say I just care about new fingerprints in the last 30 days. So I will change that to only new fingerprints, and there aren't. Everything that happened, everything that we saw happened prior to the last 30 days. So that can really help also to narrow down any issues that we want to look at. Of course, you can search by daemons here as well. You can search by the stack signature, the crash signature, sorry, either version 2 or version 1. And if you want to search by more than one string in the backtrace, you have 3 3 substrings that you can search for. So this can also help narrow down relevant issues. Yeah, there are some status search as well. It's very extensive. So yeah. Yeah. Does anyone else have any question?
Very good demo.
Thanks, Yarid, for walking us through the dashboard and letting us know how we can use it.
Sure, pleasure. Yeah, and if you have any questions, please reach out. Currently, again, as I mentioned, there's work done to improve the deduplication of the crash signatures. So Casey helped with his feedback with the bug scrub that they did on the most recent sync for 16.2.7. It's not an easy problem, and try to apply some AI tools in order to better dedupe that. So work in progress. All right, thanks everyone, and we'll see you in the next Tech Talk or any other.
At the telemetry huddle, maybe.
Yeah, you're very invited. It happens every Thursday at 12 p.m. Eastern Time. It's on the community calendar, so you're very welcome to join us.
All right, thanks everyone. See you.
Thank you. Bye-bye. Thanks. Bye-bye.